When you hear the word Europe, what do you see? Cobblestone streets, Renaissance art, the scent of fresh bread from a Parisian bakery, a sunset over the Amalfi Coast. But if you look up, past the clouds, past the atmosphere, past the silent dance of satellites, you'll find another Europe. Not on Earth, not in history books, but in the frozen dark of the outer solar system. A world of ice, of silence, of oceans buried beneath kilometers of frozen shell. This is Europa, Jupiter's sixth moon. And it is not just a ball of ice. It is a promise, a whisper from the deep cold, a place where life may be waiting, not in sunlight, not in air, but in darkness, under pressure, in water older than Earth itself. We've sent probes. We've taken pictures. We've measured its gravity, its magnetic field, its cracks. And every time we look closer, the mystery grows deeper. What lies beneath that ice? Is it dead? Or is it alive? And if it is, what does that mean for us? In January of 1610, an Italian astronomer named Galileo Galilei pointed his handmade telescope toward Jupiter. He expected to see stars. Instead, he saw 4 faint points of light, moving like tiny companions around the giant planet. At first, he thought they were background stars, fixed, unchanging. But night after night, their positions shifted. They circled. They returned. He realized these weren't stars. They were moons. And one of them, the second brightest, was Europa. Galileo didn't name it. He called it Jupiter too. He didn't care about myth. He cared about truth. But a German astronomer, Simon Marius, claimed he'd seen it first and named it after Europa, the Phoenician princess abducted by Zeus in disguise as a white bull. The name stuck, not because it was poetic, but because science needed poetry. Because without names, we forget. And without remembering, we stop looking. Today, Europa is no longer just a dot in a telescope. It is a world we are beginning to understand. And it is changing everything we thought we knew about where life can exist. Europa isn't just icy. It's layered, like a cosmic onion. At its core, a rocky, metallic sphere hotter than any desert on Earth. Heat generated by tidal forces, squeezed and stretched by Jupiter's immense gravity. Around it, a mantle of silicate rock, perhaps similar to Earth's mantle. Then, a global ocean, not a lake, not a sea, an ocean, 200 kilometers deep, more than twice the depth of Earth's deepest trench. And above it, a shell of ice, 10 to 30 kilometers thick, solid, cracked, frozen, but not static. Beneath that ice, the ocean moves. Tides rise and fall. Water churns. Currents flow. Heat rises from below. Cold sinks from above. And between them, chemistry, salt, minerals, organic molecules, all mixed in liquid water. On Earth, wherever there's liquid water, heat, and chemistry, life finds a way. In hydrothermal vents at the bottom of our own seas. In caves lit only by chemical reactions. In Antarctic lakes sealed for millions of years. So why not here? Europa doesn't have sunlight. It doesn't have oxygen. But it has something far more fundamental: liquid water. And that alone makes it one of the most promising places in the solar system to find life beyond Earth. Look at any image of Europa's surface, and you'll see something strange. Not craters, not mountains, but lines. Thousands of them. Long, thin, curving, crossing, intersecting, stretching across the entire moon. These aren't cracks from meteor impacts. They're fractures, tectonic scars, formed by the constant flexing of the ice as Europa orbits Jupiter. Every 3.5 days, Jupiter pulls Europa closer. Then let's go. The moon stretches like rubber, then snaps back. This tidal squeezing generates heat, enough to keep the ocean liquid, but it also tears the ice apart. The cracks fill with warmer water rising from below. It freezes again, forms new ice, pushes the old ice aside, creates ridges, chaotic terrain, icebergs frozen mid-fall. The result? A surface so young, so active, that it has almost no impact craters. Only 3 craters larger than 5 kilometers have been found. That means Europa's surface is less than 30 million years old, a blink in geological time. On Earth, continents drift over hundreds of millions of years. On Europa, the ice renews itself in mere millennia. And every crack, every ridge, is a window into what lies beneath. The most mysterious features on Europa are its reddish-brown streaks. Some stretch for thousands of kilometers. Others coil like veins. Scientists call them lineae. They're darker than the surrounding ice. They're chemically different, and they're everywhere. When the Galileo probe studied them, it found complex organic compounds, carbon chains, salts, even possible magnesium sulfates. But one theory sent shivers through the scientific community. Could these streaks be made by microbes? Imagine organisms living in the warm ocean below. They thrive near hydrothermal vents. They feed on chemicals released from the seafloor. As they die, their remains rise with water currents. They get trapped in the ice. When the ice cracks, they're pushed upward, exposed to radiation, chemically altered, turned red, frozen into the surface, now visible from space. Are they fossils? Waste? Living colonies clinging to the underside of the ice? We don't know, but we know this. Nothing else explains the color. Nothing else explains the pattern. Nothing else explains why they appear exactly where the ice is thinnest, where the ocean is closest to the surface. If they are biological, then Europa isn't just a world with water. It's a world with biology. And that changes everything. Europa's surface is bathed in radiation. Jupiter's magnetic field traps charged particles, electrons, protons, and flings them at Europa like a cosmic shotgun. The dose? Over 500 rem per day. Enough to kill a human in hours, to break DNA, to vaporize electronics. And yet, life might survive. Because radiation doesn't just destroy, it creates. It breaks apart water molecules, releases oxygen, hydrogen, free radicals. These chemicals can react with minerals from below, form new compounds, feed microbes. In Earth's deep oceans, some bacteria use hydrogen sulfide, others use iron. Why couldn't something on Europa use radiation-produced oxygen? Maybe life that doesn't need sunlight. Maybe it needs only water, heat, and chemistry. Maybe it thrives in the dark. Maybe it feeds on the very radiation meant to kill it. Europa isn't a hostile world. It's a paradox, a place where death fuels life, where the most dangerous environment becomes the most fertile. For decades, scientists thought Europa had no atmosphere. Too small, too cold, too weak at gravity. But in 1997, the Hubble Space Telescope detected something faint: molecular oxygen. Just traces. 1,000th the density of Earth's air. How did it form? Radiation splits water molecules on the surface. Oxygen stays. Hydrogen escapes into space. Light, fragile, fleeting, but present. And then something stranger. In 2012, Hubble caught something even more astonishing. Plumes. Jets. Geysers. Shooting water vapor 200 kilometers into space. From the South Pole. 3 times over 15 months. Each eruption lasted minutes. Then vanished. Like a heartbeat. Not constant. Not predictable. But real. And that changes everything. Because if water is erupting from the ocean, then we don't need to drill. We don't need to land. We don't need to melt ice. We just need to fly through the plume, collect the vapor, analyze the molecules, find amino acids, find lipids, find signs of metabolism. Europa is giving us a sample. Without us having to dig, without us having to risk a mission, it's handing us the answer if we're ready to catch it. We didn't always know. For centuries, Europa was just a point of light. Then came Pioneer 10 in 1973, a flyby. Grainy images. No detalles. Then Pioneer 11, same thing. Then Voyager 1 and 2 in 1979, better. Still blurry, but enough to show the cracks. Then Galileo, launched in 1989, arrived in 1995, spent 8 years orbiting Jupiter, took over 20,000 images of Europa, but they were fragmented, low resolution, color distorted. It took scientists years to stitch them together, pixel by pixel, like assembling a puzzle made of smoke. Finally, we saw the truth. The ice, the cracks, the chaos, the red lines. And then Galileo died. NASA deliberately crashed it into Jupiter, not because it failed, but because it worked too well. It had discovered the ocean, and we couldn't risk contaminating it with Earth microbes. So we ended its life to protect hers. That act wasn't tragedy. It was reverence. Now we're going back, not just to look, but to touch, to taste, to listen. NASA's Europa Clipper launches in 2024. It will orbit Jupiter, not Europa. Fly by the moon 50 times. Use radar to map the ice thickness. Measure the ocean depth. Sample the plumes. Detect organic molecules. And then, in the 2030s, Europa Lander. A robotic explorer designed to land on the ice. Drill down, melt through, deploy a probe into the ocean. Swim, search, transmit data, back to Earth, through Jupiter's radiation, through 780 million kilometers of vacuum. If it finds life, even microbial, it will be the greatest discovery in human history. Not because it proves aliens exist, but because it proves life doesn't need Earth, doesn't need sunlight, doesn't need air. It needs only water, heat, chemistry, and time. And those things, Europa has them in abundance. If we find life on Europa, we won't just find microbes. We'll find a new definition of life. We'll realize that biology isn't rare. It's inevitable. Whenever conditions are right, life emerges. Not because it wants to, not because it's designed, but because physics allows it, because entropy demands it, because energy flows, because matter rearranges. And somewhere, in the dark, under ice, in eternal night, something is breathing. Not with lungs, not with gills, but with chemistry, with movement, with memory. And if that's true, then the universe is teeming. Not with civilizations, not with spaceships, but with quiet, hidden, ancient life. Waiting, silent, patient. And we, with our telescopes and our probes and our dreams, are just now learning how to listen. We thought we were alone. We thought Earth was unique. We thought we were special. But Europa whispers otherwise. We are not the center. We are not the first. We are not the last. We are simply the first who looked up and asked. Europa is not beautiful because it looks like Earth. It is beautiful because it is nothing like Earth. It is a world of ice and pressure and silence, where the ocean is blacker than midnight, where the surface is colder than death, where the sky never changes, where the sun is just a bright star lost in the distance. And yet, beneath that ice, water moves. Chemistry sings. Life may breathe. We will never walk on Europa. We will never swim in its ocean. We may never even hear its voice. But we will know, if we are brave enough to look, that we are not alone, that the universe is not empty, that life in some form is patient, is persistent, is waiting, And when we finally find it, we won't celebrate. We'll bow, because we'll realize we were never the only ones who wondered. We were just the first to ask. We hope this journey ignited your curiosity. Stay with us as we explore the hidden oceans of the cosmos, where silence holds the greatest secrets and ice hides the oldest stories. Subscribe and join us for the next discovery.